This conference will now be recorded.
And so by showing you what we've done in the past, we hope to sort of develop and assist with future projects. So let's get cracking. So Aqua, many of you will already know us. We've been around for quite a while. 1980s is when the company started, and through the preceding decades, we've been fortunate enough to be instrumental in introducing a number of innovative products to the rail industry, some of which are still in use today, and you will see shortly. We are always looking for new innovations and new opportunities. So as engineers, as people who work on the railways, if you ever come across a situation whereby you can't find something off the shelf, give us a call, talk to us. Maybe it's something that we could look at developing and manufacturing to assist the industry in the future. So again, just a little bit about us. We are actually a family-owned company, have been since day one. About 85% of our staff actually live within 10 miles of the factory, and a number of generations of the same family actually work for our business. We're fortunate enough to have a very, very low staff turnover. Once you join Aqua, you don't tend to leave. So the first of the three product groups is track and off-track drainage. This covers catch pits, pipe, various other items that you'll see shortly. So we'll make a start on catch pits. So many of you will have seen catch pits if you've been on the rail infrastructure or indeed on a train anywhere in the last 20 plus years. In the last sort of 15 years or so, these blue lids have made an appearance. It's something that Network Rail actually were very keen on introducing to make drainage much more visible. You'll notice that our product is called the Ashford. That is named after Ashford in Kent, which is where the very first GRP lids were trialled and subsequently went on to be fully approved and used nationally. So as you can see, they come in a number of different forms and sizes, so rectangular and indeed round. So depending on whether you've got new infrastructure going in or old infrastructure, we can provide lids that suit. They have no resale value, they're lightweight, they're non-conductive, they're very, very durable. So it's the ideal product really for catch pit covers, and being bright blue, obviously they're highly visible. So these traditionally catch pits were concrete, and we still supply quite a lot of concrete, although it tends to be to Western region rather than any of the other regions in the country. Most other regions have now switched to these more sort of composite heavy systems, and you will see that top left, a traditional concrete catch pit comprising rings, half rings, base sections, etc. Top right, you've actually got a composite sump unit twinned with concrete catch pit frames. That is actually the cheapest way of putting the concrete in the ground in terms of material costs. The full GRP system, as you'll see, actually represents a much better option in terms of health and safety and installation time. The catch pits themselves typically come in two main sizes, that's standard or narrow. Narrow being often referred to as a Matissa, which is a 1035 by 575 frame, as opposed to a standard, which is 1270 by 735. So, as I mentioned, we have this GRP sump systems, which have basically replaced concrete. So a GRP sump, be it a sort of Sterling or a Watford, which are our two kind of typical standard size sump units, they replace about half a ton of concrete in using a single 20+ kilo GRP unit. So on the left-hand side, you've got the Sterling type, and on the right, you've got the Watford. The main difference between those two is the picture on the right, the Watford, you'll see it has sort of recesses on the left and right uppermost sections of the unit. That's to allow you to install rodding ledges, which then raise the operative from the bottom of the sump unit. And that's all to do with working at depth. So if you've got catch pits over 1.2 meters in depth, traditionally you'd use a Watford type so that you could raise that operative out of the ground, and then you don't fall foul of any working at depth requirements. More and more often these days, these things are cleaned out mechanically. It's less and less likely that somebody's actually going to get inside to clean it out manually with a shovel. And so the use of this type of sump unit is starting to fall as there's just not really the requirement for it. Picture on the right also you'll see has got benching inside of it. That's not something that we would typically do for trap drainage, but it is something that is possible if it's so required. It's generally something which is more regularly specified for stormwater drainage in platform environments, car park environments, that sort of thing. So where the Sterling and Watford type units both take standard size frames at 1270 by 735, be that concrete or GRP, the mini Sterling, which is the one that you can see on the left, was developed specifically for 6-foot applications and to work with the Matisa narrow concrete catchpit frames. The one on the right is a Luton unit, which is a hybrid unit. This actually came from a design engineer saying, I want a narrower pit, but I don't want a shorter pit. I want to maintain the same sort of capacity within the system, but I need to have it narrow to fit in a 6-foot. So we developed the Luton, which is exactly that, standard length, narrow width. Took it to Network Rail, and they were more than happy to approve that product as an alternative size of catch pits. So both of these catch pits are pictured with GRP catchpit frames. The Sterling, the Watford, and the mini Sterling are all suitable for use with either GRP or concrete catchpit frames. The Luton is only available with GRP catchpit frames. Concrete frames for that size of pit do not exist. So GRP catchpit frames. So where a standard concrete frame, 1270-735, weighs about 72, 73 kilos dry, the GRP frames that you see on the left there, same size, same depth, 115 mil, weigh 16 kilos. Yet they're more durable, they're less susceptible to breakage than the concrete, and they are far, far safer and quicker to install than the concrete alternative. On the right-hand side is a narrower version, same as the Matisa size concrete frame at 1035 by 575. Both of these sizes, and indeed the Luton size, the hybrid size, are available as either 115 or 225 mil deep sections. Obviously, the 225 mil sections allow you to construct a catchpit to cover level in the least number of pieces. Both of these sizes, standard and narrow, represent quite considerable weight savings over their concrete counterparts. So around 80% weight reduction in the case of the standard and about 75% in the case of the narrow. So you're talking considerable weight savings when you consider that most catch pits have between, say, 6 and 10 rings per unit. So this is not particularly scientific testing. This was just done in the yard, actually following a site demonstration whereby we went and took some materials to Reading area station remodeling, and the senior project manager for that scheme basically just picked one of these frames up and threw it across the car park, and when it didn't shatter into 1,000 pieces, that was it, he was sold, and the entirety of that scheme was then constructed using the GRP frame. So we thought that was quite a good idea, so we replicated that in the yard. So you can see on the left just throwing it across the yard, and on the right hand side dropping it onto the corner, which is in essence the weakest part of the unit. In both cases the frames were structurally fine afterwards, no issues whatsoever with them, bar a few scratches and scrapes. And then this was a more scientific test. It was an actual scientific test undertaken by a third party on our behalf, just looking at the strength differences between the concrete and the GRP frames, and also a couple of competitor products. But you'll see from both of those charts that in both instances, the Derby GRP frame actually withstood much, much higher point load test on the left and a UDL test on the right than the concrete equivalent frame. The only time the concrete frames were actually stronger was in compression, which you would obviously expect with it being concrete, but the GRP frame still took 20 tons, which for a rail environment is more than sufficient. All the loading is really a lateral load, either static or dynamic, when you're talking about track drainage rather than vertical loads. Again, not a particularly scientific video, but just to sort of show and highlight the difference between the old traditional concrete systems and the new GRP composite system. So on the left, 2 older gents, on the right, 4 young lads, concrete versus GRP. And in this sterile environment where you're not having to lower anything into a trench, you know, check things with levels, make sure it's level, pick it up, reset it, etc., you'll see they actually managed to, in inverted commas, install 4 full GRP systems versus 1 concrete. So even though the GRP is more expensive to buy, actually the whole cost of procuring it, getting it to site, installing it, and then maintaining it is actually far lower with a GRP system than with a full concrete. So with the GRP, we can also offer a bespoke manufacturing service, so you don't have to have those standard sizes. And this particular chamber was something that was done for Carillion as part of the Old Oak Common Paddington Approaches project, UCPA, if any of you are aware of that, West London. They had to install a drainage run, which the OLE guys then helpfully came along and put a pile straight through. And so the drainage team then had to go in and rectify. So the original plan was to install 4 catch pits, 2 of which would have been buried underneath all the ballast and rail that you can see on the right-hand picture. And so we created this elongated catch pit system to allow them to dogleg around the structure without actually having to install any more than 2 chambers. So the bottom sections, as you can see on the left, were sprayed, so they were solid and watertight. And then on the left, you've got the stackable frame so that they could adjust for height on site as need be. And if obviously a tamper comes through or there's a renewal that takes place, then the catch pit cover can be lowered to 400 mil below sleeper, and that operation can take place safely without interrupting or interacting with the catch pit itself. So crew adapters, very similarly, crew adapters and York adapters, they're more for network rail maintenance teams than for contractors. The crew adapter allows you to reduce the footprint of a catch pit at ground level, going from standard to narrow or Luton, whereas the York adapter allows you to put GRP frames on top of concrete. So network rail maintenance can chuck a load of GRP frames in the back of a van, go out and do a day's work replacing broken frames, knowing that they can connect easily onto existing concrete infrastructure. So that's the sort of rectangular pits done and dusted. The Stafford is a hybrid pit that's developed a fair few number of years ago now, and that utilises a round base with a rectangular top. You can either have it with concrete frames or GRP. The GRP system now uses the transition frame that you can see bottom left, and that allows you to bolt the frame to the top of the unit. What this unit allows you to do is have a much larger range of pipes entering and exiting the catch pit at a variety of different angles without really affecting the structural integrity of the rectangular system. At ground level, you then maintain that uniformity of the rectangular footprint, but underground, everything's going on that needs to. These are not the ideal solution in that network rail don't like round drainage catch pits. The Stafford is a compromise that they seem willing to make when necessary. Then we have our SE units, which are our round units. So these have come on a long way from sort of traditional circular plastic catch pits. You will have seen, I'm sure, circular twin wall catch pits around and about. They are nowhere near as strong or as durable as this particular system, which is actually manufactured using an extruded box section, which is then spirally wound around a former to give around 20 plus different diameters, from 400 mil internal to well over 3 meter internal diameter. We can actually manufacture these chambers as up to a 12 meter single piece chamber, although that's extremely rare. The deepest we've done is about 6 meters for a water industry scheme. And top left, you can see a couple of examples of some of the larger chambers that we've manufactured and delivered to the rail industry for a variety of different schemes. But the chamber itself, very, very simple to use, essentially an alternative to a concrete manhole, comes as a single piece, doesn't necessarily need a concrete base or surround, lightweight, durable, wide range of lids available to suit pedestrian loading, highways loading, etc. So very, very versatile. Can be used for foul water drainage, storm water drainage, track drainage, whatever it needs to be. And that's kind of catch pits done and dusted. So you're seeing from where the old traditional concrete products have come a long way as material technologies have progressed, and there's now a variety of different options available. Track drainage pipe is sort of similar. Traditionally, it was clay and concrete. We can supply clay and concrete, although we very, very rarely supply any clay drainage anymore. Twin wall plastic drainage, our TDK product, is more than suitable for use as a cess drain, available as either a carrier drain, half perforated or fully perforated collector. We do have some information which I'll show in a minute about placing different pipes in different situations. It's all to do with distance from track, loading that the pipe is anticipated to be withstanding, and therefore selecting the appropriate material type rather than just a blanket. You must use X, Y, or Z. So TDE is our solid wall pipe, so that sits alongside the TDK, but it's a much, much stronger product. It gives us the ability to sit the pipe much closer to the track and for it to withstand considerably more loading. So ideally suited for kind of UTXs, 6-foot drains, those sorts of areas where you anticipate that the pipe is going to be subjected to much more difficult conditions than a traditional cess drain might be. So this particular product comes in 3 different wall thicknesses. It comes in a variety of different lengths, and it comes as either a perforated or solid carrier or collector drain. And this is a little diagram just to try and allow you to sort of visualize where the different types of pipes go. So the blue zone is kind of TDK, and then the colored zones, green, yellow, and orange, will be the 3 different types of TDE that we do. And then the red zone, it's not to say that you can't put a pipe there, but we very much need to know more information about ground conditions, loading conditions, etc., before we can specify or recommend a particular product. We have the ability to run calculations in-house, so if you ever have questions or queries about what pipe to select, just talk to us and we'll guide you through that process and allow you to select the strongest pipe that you need, whilst kind of bearing in mind that you don't always need the strongest type of pipe, which coincidentally is the most expensive. TDX is our large diameter pipe. It's exactly the same as the material that we use for our circular catch pits. So it's that spirally wound material, 400 mil through to over 3 meter internal diameter. We tend to use this for culverts and for connecting to existing structures, which is what the top left and top right pictures are. The one on the left was an arched culvert that we constructed a bespoke connection piece for, and the one on the right was a circular culvert, but the connection had to happen at 45 degrees, so it was actually an angled connection piece. And then bottom left was a scheme up in Scotland where they just constructed a brand new crossing and then had the pipe protruding from that sort of rock stone head wall. So this pipe has very, very high UV resistance. In the UK, based on UV exposure, you can get 60 plus years above ground and 120 years in the ground. And that's very similar actually to the rest of our pipe products. They all have very high UV resistance because we recognize that with rail schemes, it's not just a case of deliver the materials to site, it goes in the ground, gets covered up, and 60, 70, 80 years later, it gets dug up again. These sorts of products turn up on site, jobs get cancelled, jobs get postponed, they're exposed to the elements, to UV, and you need to know that if that product's been sat around for 6 weeks on site or longer, when you put it in the ground, it's structurally sound. So track and off-track drainage. There's a variety of products here, but it's sort of everything that isn't pipe and catch pits. So trench liner is exactly that. It is a geotextile liner for your drainage trench. It meets the Network Rail standard perfectly. It's highly permeable, highly flexible, durable, but it's designed for lining trenches, not separating formations. Then we have the composite headwall, which is a new product. This has only been around maybe 18 months, 2 years now, and this is an alternative to the traditional concrete head walls that you will have seen line side next to highways and housing estates, etc. This came about from a contractor a head wall, but they couldn't install a concrete one because it was too heavy to install by hand. They couldn't install it using road rail vehicles because they didn't have enough reach on them to be able to lift the concrete head wall into position. So then they had to start looking at heavier duty lifting equipment, cranes, etc. It soon became apparent that the cost of doing the job would be, ridiculous when you factor in the requirements for the cranes, etc. So they had to come up with an alternative solution, and we constructed this GRP system for them as an alternative, and it's gone from strength to strength. They've been used nationally, actually started in Kent, but they've been used in the West Country, they've been used in Wales, they've been used in the Midlands, they've been used in Scotland, variety of places across the country. They seem to be a very popular product, not only with projects, CapEx teams, but also maintenance teams, because they are essentially manhandleable. The off-track teams can actually order these in and install them very, very simply. Ditchliner is exactly that. It's a plastic liner for drainage ditches. We do a smooth version or a corrugated version. As you can see from the pictures, the corrugated version is more suited to flumes or areas where you want to try and slow the flow of water, dissipate some energy, whereas the one on the right, the smoother one, is ideal for kind of crest drains, that sort of thing, where you want to just collect the water and convey it from point A to point B as simply and as smoothly as possible. So actually Network Rail came to us and said, we are interested in concrete canvas, but that product has its drawbacks, its limitations, and so we're looking for something to complement that, and that's where the Ditchliner came from. So it doesn't replace or kind of compete against Ditchliner as such. It's an alternative product that can be used and installed very quickly, very easily. They come in 2 meter sections. You can stack 5 or 6 of them up easily, and 2 men can lift them, move them around on site, pin them into the ground very, very simply, very, very quickly, as opposed to the concrete canvas, which you generally need RRVs to hold the material to allow you to roll that out. You require more manpower to roll it out, etc. Composite trough drain covers. Again, this was another thing that Network Rail sort of came and spoke to us about. There's a huge amount of concrete trough drain out on the infrastructure that was ripped out because the lids were broken and they got clogged up with leaves, silt, dirt, debris, and there was drainage issues, so they were ripped out because the trough wasn't available anymore, the lids weren't available anymore, and so they put in piped French drains predominantly, then found that they're just not as efficient. So rather than just ripping out a perfectly good trough, we actually do these GRP grated covers, again in high visibility blue so you can see them, to replace any damaged infrastructure without having to actually rip out the whole thing and replace. Where it does need to be replaced, we actually have the Aqualine composite drainage trough, which is essentially 300 by 350 drainage channel made out of GRP, so it's nice and lightweight, comes in 2 meter sections, easy to install. It's only about 16 kilos per section, and it can be used line side, as you can see from the picture on the right, which was the scheme up in Scotland. Very, very simple to use. The one on the right was kind of pre-production prototype, if you like. It didn't have the blue lid. All Aqualine troughs now are supplied with that blue grated lid again for high visibility. And that's really drainage. We do a variety of different products, as you can see, but generally speaking, there's kind of traditional drainage, which is your track drainage catch pits, and then there's the kind of the more interesting things that have come about from people saying, can you do this? It would be great if we could have and that's where we've really developed our range of products. So cable management systems, I'm not sure how many of you guys are particularly interested in this, but essentially using the same chamber type as the circular drainage catch pit, we can construct watertight chambers for cable management systems. So selection of different chambers there for you to see. Typically 1200mm internal diameter is a standard UTX size, but as I said, there's a wide range of sizes available, so we can always produce a chamber that is suitable for bending radius of cable, number of cables, etc. So with the UTXs, they've been around for many years. There's a variety of different options available, from spigots, from cable hangers. The picture on the right, you might just be able to see right at the bottom, just above the text, there is actually a drainage pipe that runs through that UTX. So rather than having to resite the UTX because it clashed with the drainage, or renew the drainage because it clashed with the UTX, we actually managed to combine the two so that the drainage ran straight through the chamber. The pipe is completely sealed, so drainage can't leak into the UTX chamber. But it just meant that the UTX chamber could be sited exactly where it needed to be, and it didn't impact the drainage. Individual spigots, as you can see on the left, multi-duct spigots, as you can see on the right. That's actually the sleeve, the multi-duct sleeve that we do, which actually gets around having to have a fixed point on the chamber to connect the multi-duct to. But we can also do that as well. The multi-duct system is a very popular system for under-track crossing duct routes because it's narrower and shallower than the equivalent individual ducts, as you can see on the left. Both of those are 6-ways, but it's not watertight, and it can be tricky to connect chambers when you haven't got an equal number of sections. So we do the sleeve option, and then, like I say, we do the individual duct option as well, so depending on what you need. The individual ducts you can see there are twin wall, TDK, but we also do them as TDE, solid wall duct. So if you've got high water table area, TDE, individual duct, is the only option to get you a watertight crossing without the need for any concrete to be introduced. So we do the big chambers. That's probably one of the products we're most well known for, but we also do much smaller versions for platform lighting schemes, depot lighting schemes, etc., which is what you can see are the chambers on the left are, and then the right is just a typical installation in a platform environment. Ones on the right have got circular lids on, ones on the left have got square lids on, just showing the versatility of the chamber type. Cable ducting is exactly the same as drainage pipe, but obviously it's supplied without perforations in it. So you can have the twin wall or the solid wall, depending on what you use. It does influence the depth at which you can install it as an under-track crossing. When running line side, we can actually do, as you can see on the left, buried root ducting, and that comes in either 4, 6, or 9-way configurations, 6 meters long, line side under platforms. There's no issues, and that's just a much quicker way of installing multiple ducts, similar to a multi-duct system, but you can have that as either 100 or 150 mil, like I say, as a 6 meter section or a 3 meter section, as opposed to a multi-duct, which is only a 1 meter, so much quicker installation times. We then do either the circular chambers to suit, or as you can see from the picture on the right, we also do GRP chambers, much like our sump units, to allow you to connect and then use as intermediate pull-in chambers or joint bays if you need to. Split ducting is something that we actually supply rather a lot of. So on the left is a twin wall split duct, either single or double split, generally double split because it's easier to install cabling into, just comes as 2 halves which you then piece back together. And then on the right hand side is actually solid wall split ducting. This was done as a bespoke scheme for a project in West London, part of the HS2 enabling works, whereby we actually created a UTX from the split duct, and it had a series of bends and invert changes within the system. So it was all fully fabricated to suit, and then the little grey box that you can see on the end there was a transition back to a trough. So again, just sort of showing the bespoke nature of some of the things that we can do and the capabilities we have as a manufacturer. That there is a rectangular GRP UTX chamber, which we actually construct using our Derby frames. So again, rather than using it for drainage applications, we can use them for cable applications. So we spray them, as you can see from all 3 pictures. So you get a single piece unit, which is watertight, and we can then connect into it with a variety of different ducts. So top left, you've got individual duct, bottom or on the right-hand side, you've got multi-duct. And then the one on the bottom left, that had a multi-duct connection, and then the little thing that you see sticking out on the left-hand side is actually a spigot, trough spigot, with a cable trough into the unit as well, and allow the contractor to seal around that joint between the two. Picture on the left is actually a trough spigot, and then on the right you've got handrail and warning signs. So with regards to UTXs, we essentially do everything you need, from chamber to ducting to marker post to draw cord, warning tape, you know, all the sort of ancillary items that go with it, turn up with the chambers, with the ducting, and then all you really need is manpower and stone to install. Everything else will come on our delivery. Mast chambers, again, that can be done either as a round option or square or rectangular. This is about enabling the installation of a vertical structure within a pedestrianised area, maintaining access to the holding down bolts without posing any tripping hazards. So this actually first came about from a scheme in Wimbledon, whereby the contractor there was told to put up some release structures. They were told to that they couldn't bolt them down at surface level on the platform because that was a tripping hazard, but they couldn't bolt them down below surface level and then tarmac over them because Network Rail wouldn't be able to gain access to the bolts and therefore couldn't do any maintenance checks. So they had to come up with a solution. That's when they approached us, and that's when we came up with the idea of using either the SE type chambers or the Derby type chambers without a base, and then with multiple section lids, which then have the cutout in them to enable you to have that mast structure or vertical structure coming through them. Bottom left was actually part of the WAML scheme, which was a North London scheme, which is for the West Anglia main line. And that didn't actually have a chamber. That was a blockwork chamber just for the two-piece lid and frame assembly then at platform level to enable access as required. Additional services, not really for you guys, to be honest. Essentially, contractors will come to us with an AFC drawing. We'll then produce a takeoff, which you see bottom left. We'll quantify everything, we'll check everything for constructability, and then fabrication drawings will be issued for sign off prior to any manufacturing taking place. And then BIM models is more for obviously designers. We have BIM models of all our products, which we can share as required. Last section, which I'll get through very quickly because I'm conscious of time, is geotextiles and geocomposites. So there's ourselves and Teram essentially, who have product approvals for supplying geotextiles and geocomposites to the rail network. The main thing to remember with our geotextiles is they're they're needle punch non-woven, not heat bonded, which is what Teram products generally are. What does that mean? Well, essentially, we get a big ball of fibres. They go through through a set of rollers, and then there's a needle punch machine that meshes those fibres together, and so you get a material which is highly flexible, highly permeable, very, very good at resisting abrasion. Whereas a heat bonded product, again, big ball of fibres through rollers, but the rollers are then heated, or the fibres are heated, and they stick together. So you get a product which is much stiffer, more akin to a thin cardboard than a flexible material. Doesn't deal with abrasion as well, is nowhere near as permeable, and so is much more difficult to work with than the equivalent needle punch materials. So we've had a number of tests done over the years, both scientific and non-scientific, as you'll see in a second. And in comparison with the Teram product, which is that heat bonded, you'll see that both of our Teratex products, which are equivalent, fare far better in abrasion testing because of the way that these products are made. So this is another one of our non-scientific tests. On the left is a Teram PW1, on the right is a Teratex, and essentially it's over a bucket with a weight on it to hold it in place, and then pouring of water on top. You'll see that the Teram product ends up with a ponding on top. That's product because it needs a 50 ml head of water before there's enough pressure to actually force any water through the geotextile, whereas the Teratex product on the right, the needle punch material, requires 0 head. The water can actually permeate through that material far easier and dissipate away from the track environment. In terms of pore size, so in terms of particle sizes that are able to pass through these two materials, they are essentially the same. You're not getting any benefit of using the heat bonded product over the needle punched. All of the benefits come from using that needle punch product because you can pass water through it much more efficiently. In terms of numbers, Teram PW1 is about 35 litres per metre squared a second, whereas the Teratex is about 70 litres. So it's a big difference. Again, not particularly scientific. Pot of sand, piece of geotextile stretched over the top of it, metal weight with a point on it, drop it down the tube, it hits the geotextile. You see the one on the left, the Teram, it's just punched straight through, whereas the one on the right, it's actually retained the weight on top of the geotextile. And that's all to do with the way that the fibers interact with one another when pressure is applied. So the heat bonded, the bonds break, and that results in a tear, whereas the needle punch material, the fibers actually will move and give and enable them to sort of absorb that pressure, therefore not tearing or breaking. So not particularly scientific, but just shows the differences between this heat bonded and needle punched materials. So all of our geotextiles, which is from this point onwards, are based around that needle punch method of manufacture. So you get very flexible, good abrasion resistance, good permeability, etc. So Teratek 70 is essentially our equivalent to a PW type product, a PW1 type product. Good separation, good for kind of medium to high abrasion, although we tend to market it as low to medium abrasion. And we then have Teratex 4050, which then sort of sits on top of that. But essentially, this product works perfectly well in a mainline railway situation, gives good separation, good abrasion resistance. But Teratex 4050 is one step above. It's a better product again, more akin to a PW1 plus, if you will, if such a thing existed. Stronger, more durable, is going to be longer lasting. So we tend to recommend, if you've got mainline routes, high traffic, high speed routes, Teratex 4050 is the optimum product to go for if budget constraints will allow. If not, Teratex 70 is a better product than a PW1, but you're not getting the best product that you could. TED 2 is a composite product which combines Teratex 4050 in 2 layers with a drainage mesh in between, designed specifically for areas where you're going to have very high abrasion and or you've got drainage issues with the formation and you need to improve or increase lateral drainage across the formation rather than through the formation. Because it's a composite, comes in smaller rolls, it's more expensive than a geotextile, but by introducing that mesh, you can, as I say, encourage that lateral movement of water, which can be very advantageous at times. TED 10 is just a geotextile, thicker version of Teratex 4050, and it sits alongside TED 2 in that it's designed for use in very aggressive, high abrasion risk formations, but being just the geotextile, it's cheaper, it's easier to work with, but you don't get as good lateral drainage as you do with the TED 2. So it's about picking the right product for the right application. So in terms of numbers, again, just to give you an idea, Teratex 4050 is at about 3,700 Newton meters. Puncture resistance, TED 2 is about 7,500. And TED 10 is 10,000 Newton. So it's a very strong material. Permeability does go down a little bit with TED 10, but when that abrasion issue is the key concern, TED 10 is the product of choice. Teratex is a very innovative product that we introduced probably getting on 10 years ago now, 11, 12 years ago now. It is a sand blanket replacement geocomposite. So the idea is that a 20 mil thick geocomposite replaces 100 mil of sand. So picture on the left, it's a bit fuzzy, I'm afraid, but it's a half sleeper rig, which was originally constructed as a clay formation. That formation was then basically pounded until it failed. They were applying water the whole time so that they got the clay slurry that you can see on the bottom of the picture on the left. Once that happened, they stripped all the rail off, all the sleepers off, they installed the Teratex product, and then they ran the test, I should say, 70 million gross tons of traffic, and then stripped it all out. And as you can see, it's completely dry. The way that the product works is it's a micro-porous filter sandwiched between 2 layers of geocomposite. The filter is small enough to only allow extremely small particles through, which essentially means that only water can pass through under pressure. So when the product is in the track and there's no trains running, it's essentially impermeable. As the train runs over that section, pressure exerted forces water through the microporous filter. The fines are retained beneath, the water passes through and then runs off on the crossfall, therefore drawing any water out of your wet beds, returning strength to your formation. And as I said, it replaces that 100 mil of sand. So in terms of installation, you can generally install twice as much Teratex in the time that it would take you to install a traditional sand blanket, on top of the fact that you can then save yourself nearly 10 cubic meters of material to be removed from site, and then all the sand and everything else that needs to come to site by using this composite material as opposed to bulk sand. Installation is so simple, it's untrue. TED4 is Teratex with a grid bonded to it. So this is about introducing stiffness to the formation, especially good on high-speed curves where you want to prevent lateral movement of the formation. Because we use the Teratex product, which is that needle punch product that I mentioned, you get very good elongation, which means that the ballast can actually lock onto the grid, even though the grid is essentially bonded to the geotextile. If you have a heat bonded material, then what tends to happen is the material, the grid, is bonded to the top. The stone aggregate sits onto the top of the grid, but it can't lock in properly. So it sort of just sits on top. You don't get as good interlock, you therefore don't get that additional stiffness, lateral support that you might need. So generally speaking, most network rail specifiers prefer to use separate layers of grid with a geotextile, but because you can get that interlock with the TED4, it's a viable option, and we supply hundreds of rolls a year because it's much easier to install as a single product. The grid as an individual product has a memory and it wants to roll up on itself, whereas as a bonded product, it tends to stay a lot flatter, a lot easier to work with. Rail grid, as I said, rail grid geogrid is that grid on its own, can be introduced as a single layer or as an additional layer to TED4. This is sort of the old way of doing it before that bonded product came along, and then it's kind of gone full circle and moved back to the individual product. Like I say, because you get that interlock with the needle punch material that you don't get with the heat bonded, that single TED4 product is a time saver on site. Geoweb, it's a relatively old product actually. It was developed by the US Air Force for creating runways wherever they wanted them. It's a relatively new concept to the rail industry. Essentially, it looks a bit like a honeycomb, comes as a flat pack, and you sort of pull it out concertina style, peg it into place to open the cells, and then you pack the cells with your medium of choice. Rail work is generally sand because it means you can get good compaction, allows you to build a very stiff, very stable base to actually then construct the formation on top of. As you can see from that picture, you can actually run construction traffic straight over the top of the Geoweb. Once that material is packed into those cells, it's extremely strong. All you need to do is make sure that you've got a minimum of 50 mil surcharge over the top of the Geoweb so that the tracks on the construction vehicles don't snag on the Geoweb and damage it. You can literally just roll out full of material and drive straight along. It's very good stuff. Comes in a couple of different cell depths, 100, 150, 200, 250, 300 mil deep, and then a couple of different panel sizes as well. So for track renewals, we actually do 16+ meter long sections to speed up the installation process. Generally speaking, it's a 2.6 by 8.3 meter panel, but different things are available depending on what you need. Again, you can see the Geoweb top left and on the right. That's it without any fill material in it. You get that honeycomb structure. And then this is a 16.6 meter panel, 3.9 meters wide. And it's as simple as that. You hold it in place at one end, you pull from the other end. That's 16 meters in place. Peg it into position or use sandbags to hold it. We also have stretcher bars as well, and then you can then start filling that with sand in driving construction traffic straight over the top of it. Very, very quick, very, very simple to construct, and you get very, very good stiffness for the formation. So whether you're going over very soft ground, whether you're transitioning on and off of the structure and you want to have a sort of graduated increase in stiffness as you come on and off that structure. Very, very good product to use. And then last but not least is Root Barrier X, which is an invasive species product. Japanese knotweed probably being the best known of the invasive species. It's a copper foil between two layers of Teratex, and the copper essentially prevents the growth of the knotweed through the material. So you can either roll it out and put it down over an area, or you can treat the area and then put the Root Barrier X down as a preventative measure to prevent any further growth should anything have been missed. And that's it really. I've kind of whizzed through a lot of stuff, but hopefully there's something in there that you found interesting or informative. If you've got any questions, I'll happily answer them.
Thank you for that, Dave. I have to say, your range of products is quite considerable. I certainly learnt something there. And it was interesting to see the innovations you bring into the party as well, certainly with the GRP products. And I hasten to add, Ashford gets its claim to fame being named after one of those first catch bits. So good stuff. Just a question. You mentioned a lot about various different projects and network rail. Are these bits of kit being supplied to any of the light rail systems, be it DLR or London Underground?
Yes, we supply materials to DLR. We used to supply materials to London Underground. All of the geotextiles are used by London Underground. They use our products exclusively in terms of geotextiles. They use Tratex, Teratex, TED 4, and TED 10 primarily. They won't use, generally speaking, any Teram products. One of the engineers there just was not sold on the Teram product, so he's stuck with our products over the years. Drainage-wise, we used to supply materials, but there's a very long story. Essentially, there was an incident where somebody drove over a product with a telehandler and then tried to sort of pass that damage off as something that we delivered, and we obviously refuted that. And the long and the short of it is we stopped supplying drainage materials to the underground. But a lot of the people that were involved in that are no longer there, and there is a new drainage engineer there now as well, who we are in the process of speaking with and trying to kind of redevelop that relationship.
Okay, very good. I have a question in the chat box from Peter. He's asked, I might have missed it, but how much of your product is made from recycled materials?
Okay, so I didn't really mention anything on that front. The glass fiber strand that is used in all of the GRP products, the glass is 100% recycled. The resin is virgin product. Nobody has successfully managed to recycle GRP back into GRP yet, although I'm sure as the usage of the product continues to grow, that will potentially become different. In terms of the plastics, so the circular chambers, the pipes, they are all manufactured with varying degrees of recycled material in them. So the twin wall and the solid wall have got the highest contents of recycled material in them, and the TDX stuff is slightly less, but they all have elements of or percentages of recycled material in.
Good stuff. Good stuff. Just in case anyone else has got any other questions, just put them in the chat. But you mentioned obviously, and you showed the videos, and I know you said certainly with the GRP products, the catch pits, it was, if you like, a neutral environment, not sort of live on site. But I think it was quite powerful. You know, the message it conveys, obviously it's quicker, it's easier, it's lighter. So I think your message certainly come across loud and clear with the GRP products. Does anyone else have any questions for Dave? If not, I'll ask Phil to do the vote of thanks.
Yeah, just a quick one, Dave. Matt Adams, TME, Faversham, Kent. First of all, thanks for the presentation. I'm quite interested really in the I don't know if it'd be the right usage for it or not, that your root barrier X, we're having an issue now with our off-track teams are really struggling to get around it and sort of complete all their work. I don't know if this would be a good idea to use at some of our access points where they're constantly going out and these access points are getting close called for being overgrown, and they then have to send a team out to sort of clear them. I don't know if we could sort of put down a certain width of this and then almost forget about it, you know, and sort of would that work?
It definitely will. It depends what sort of vegetation you've got on site, though, to be honest. Using the root barrier X could prove to be a very expensive.
I was going to say, yeah, probably over-engineered for that, is it?
Yeah. So Teratex actually does offer reasonable protection against vegetation growth. I've used it many a time in the garden actually, and I've had no issues whatsoever, and so have many other people. But we do also have, which aren't really mentioned because it's not generally something we do a huge amount of, but we do have access to a number of vegetation barrier membranes, which are a cheaper option than the invasive species root barrier, but will perform the same sort of job.
Well, I'll copy down your email now. I'll drop you an email after this, David. That's all right.
Yeah. I was going to say, take down my details. Either drop me an email or give me a call separately, and we can go through the options available and some of the costings and see what you think and where we go from there.
Top man. Cheers, Dave. Thank you.
Thank you, Matt.
Hey, Colin,
Thanks.
shall I?
Yes,
can you hear
Phil.
me?
Yeah, I can hear you, Phil. If you could do the vote of thanks, that'd be very much appreciated.
Okay, thanks, Colin. Yeah, Dave, excellent presentation. Didn't realise the sort of coverage of the Aqua products. You know, not just track drainage, but you know, formation treatment, cable management systems, which is certainly something I've been involved with on HS2 recently, and of course the vegetation management. You know, there's lots of things there. Certainly for HS2, there's massive opportunity here for your products. You need to talk to the bidders, the track contractors who are bidding for the work. But yeah, as I say, really comprehensive presentation, very well described and very impressive. So thanks very much for coming to the Ashford section to give us the talk today. It's much appreciated on behalf of everybody. Just like to say thanks very much. Yeah, from the Ashford section. Yeah, thanks a lot.
Thank you, Phil. Very much appreciated. Like I say, I really do appreciate being given the time to talk to you. As you said, I mean, Aqua have been around for a long time, and most people know us for one thing or another, either drainage, cable management, or perhaps the geotextiles. But don't necessarily realise the full range that we have available and the full range of capabilities that we have as a manufacturer. So it's great to get these opportunities and chat to you guys about some of the stuff that we can do, because it really does seem to act as food for thought.
Yeah. Okay. Thanks, Dave. Much appreciated.
Thanks for that.